This video is a demonstration of the issue described in the logistic regression chapter about how the association between a dichotomous variable, such as yes, no, male, female, diagnosed, not diagnosed, and a normally distributed continuous variable cannot exceed, theoretically, 0.798, and that was shown by Gradstein 1986 analytically. So let me just show you a demonstration of that with some real data. So what I've done is I've simulated some data that are continuously scored. This is the dependent variable, and I've got a total of 300 cases. Now let's just look and see that this dependent variable is normally distributed. So let's look at that. So here's the distribution, quite normal. And we have skewness of 0.03, which is essentially 0, and kurtosis of negative 0.225. So this is a normally distributed set of scores. Now the next thing I'm going to show you is that the grouping variable here, that I've got zeros and ones, and it's an equal sample size, so I've got 150 zeros and then 150 ones, and let's just say that it's a group membership type variable, which in binary logistic regression you'd be predicting group membership, some kind of classification of some sort. So when I actually show you this, I've actually separated it in such a way that there's clear discrimination between the two groups on the dependent variables. Let me show you that. So here you can see group 0, which is scoring lower than group 1, and it's essentially perfect discrimination. This is a little bit of a binning issue. Rounding and binning is overlapping things here in the histogram, but there is actually no overlap between these two groups when you actually look at the raw data. And so this is perfect discrimination. And so if you wanted to estimate a correlation between the dichotomous variable and the continuously scored variable, you might think, well, there's essentially perfect discrimination, so the correlation should be 1.0. But as Gradstein showed in his paper, that is not how it works in practice. There's a limitation with the point biserial correlation. It can't exceed 0.798, and I'll show you that that is essentially true based on these data by looking at the correlation, which in this case is a point biserial correlation with a dichotomous variable. We'll look at what that correlation is. And so here it is, 0.806, which is essentially the same as the 0.798 suggested by Gradstein in 1986. Now, if we take it one step further with the Nagle-Kirke correction factor, which I describe in the textbook, as a correction or adjustment to an association between a dichotomous variable and a continuous variable, such that it can reflect fully the actual discrimination between the two variables with respect to the continuous variable predicting the dichotomous variable, this correlation in this case, or this association, should be 1.0. And that's what we'll get if we do a logistic regression. So let's go regression, binary logistic, and we'll put the grouping variable as the dependent variable because that's how we usually use logistic regression, is to predict a dichotomous or some kind of categorical variable. And now the dependent variable is turning into the predictor variable. So click OK, and we have here the Nagle-Kirke R squared. See how that's 1.0? That is the correction, that's the adjustment. Basically, Nagle-Kirke is taking into consideration that this is the maximum correlation that you could possibly get if you use something like a point biserial correlation, even though you actually have perfect discrimination with respect to your continuous variable and your dichotomous variable. And so Nagle-Kirke comes out at 1.0, which is arguably what it should be. Now look at Cox and Snell R squared. Here it's 0.75, which is essentially the correlation squared that we had here. So if I square this 0.806 times 0.806, I get 0.649, which is closer to what the Cox and Snell R squared is. So this is showing you that Cox and Snell R squared and the point biserial R squared are not exactly the same thing, and I do make that clear in the textbook that this is essentially similar to an R squared value, but it's not exactly the same. And then the Nagle-Kirke R squared is an adjustment to reflect the fact that the maximum possible correlation is essentially 0.798 or 0.80, and so there's an adjustment made on that basis.